Hello, this video is going to review Chapter 8 in class example problem number 2, which states the 92 million Americans of age 50 and over control 50% of all discretionary income. AARP estimated that the average annual expenditure of restaurants and carry-out food was $1,873 for individuals in this age group. Suppose this estimate is based on a sample of 80 persons and that the sample standard deviation is $550. What is the 95% confidence interval for the population mean about amount spent on restaurants and carry-out food? So for this problem, because they are asking for a confidence interval specifically about population mean, we have one of two formulas that we can use. We have the formula that uses a z-score, and we have the formula that uses a t-score. And the way you know which one to use again is by looking at which standard deviation you have been supplied. If you have been given the population standard deviation, or sigma, then you're to use the z as your value. If you have sample standard deviation, as in this problem, then because we are given s, sample standard deviation, we have to use a t value. And I'm going to call it the critical t. I'm going to put a little asterisk on it so that we know that it's not from a formula, but it's going to be a number that we get from a table. So we're going to pull the confidence interval formula for means that uses the t value. So I'm going to write that formula down. So that confidence interval formula is x bar plus or minus a t-score, I'm going to call it t star, that corresponds to the amount of area in a tail, so this is alpha divided by 2, times the standard error, which would be s divided by the square root of n. It's very much like the formula that we had with the z-score. If a z was here, then this would be a sigma. Now we just need to pull our given information and substitute them into their respective locations. So the first thing we need is an x bar. We need to figure out a t value that corresponds to the confidence level, so I'm going to call it a t star. We need to know our sample standard deviation, and we need to know our sample size. And we're going to just pull these pieces of information right out of the given paragraph. So if we go back into the paragraph, we can see that we had an average of the sample of $1,873. And I'm going to skip over the t for a minute because I'll have to switch to a chart. So I'm going to go ahead and grab the other data. So we have sample standard deviation at 550, so that'll be our value of s. And in this particular problem, we had a sample of 80 persons, so that'll be our value for n. So what we need is our value for t. What we need to know is the level of confidence in our problem is 95%. And remember that if you are dealing with a confidence interval of 95%, then that means that in the t distribution, which looks very much like a z, and that it's a unimodal, symmetric, bell curve like graph, we still have that confidence interval amount is what's trapped in the middle. And so what we need for the table we're about to use is the area in one of the tails. And because of symmetry, the area in both tails is going to be identical. So if we have 100% of our data under the curve and 95% is trapped in the middle, then that means that our remaining 5% has to be split between the two tails. And so that's going to leave us 2.5% in the left tail. We would also have a matching 2.5% of area in the right tail. For the table that we're going to use, that area that's in a tail, we need to convert that to a decimal. So we're going to make that 0.025. And what we're going to be getting from the table is the location of where that line is that cuts off that percentage of area in the left tail. So you're going to switch now to the t distribution table, which is located in Appendix B. In the back of your book, it should be the second table, and it should tell you that it's the t distribution table with a little description of how you read it. This is going to require you to know the area in the upper tail, but the area in the upper tail is going to match the area in the lower tail, so it really doesn't matter which one you grab. You're going to find that across the top, so you locate that area. That's going to be the column that your answer will be found in. The row that you're going to end up going across is what we call a degrees of freedom number. The degrees of freedom number can be abbreviated as DF, and it is given to you by a formula associated with the type of problem that you're doing. Usually it depends on the number of samples that you've drawn. And so we have a one sample scenario here. We had one group of 80 people, and the degrees of freedom formula associated with one sample is simply your sample size minus 1. And we know our sample size is 80, so if we subtract 1, that's going to give you a degrees of freedom of 79. And this would then be the row that we would travel across. So you're just going to turn the pages of your table until you find that you are on row 79. Here it is. And you want to again look for your column heading and get yourself in your column heading of 0.025. And where 0.025's column intersects with row 79, that's going to be the value that you need for your t-score. So we have 1.990 as our t-value. Notice that this is not the same as the 95% confidence interval for a z-score. The z-score answer for 95% was 1.96. This is a little bit bigger, and that's going to give us a larger number to multiply by, which will make our margin of error a little bit bigger. So we will get different answers because we are using those t-values. Now it's just a matter of substitution. Use your calculator, take your time with those calculations, and then we'll write up our interpretation. So we begin with our estimate, 1,873, to which we add and subtract our t-value of 1.99, which is getting multiplied by our standard deviation for the sample of 550, but that's being divided by the square root of the sample size, which is the 80. Again, to the right of your addition and subtraction sign, that's called your margin of error. So when you type in 1.99 times 550 divided by the square root of 80, you should get 122.3688. And we are rounding to 4 digits because we have more math to perform. We still have to perform the addition and subtraction step. So it's important that you don't round too early. So take it out 4 digits to help keep that answer as accurate as we possibly can get it. So now we're going to move into the actual interval itself. And so we're going to take the 1,873 and subtract this 122.3688. And that'll give us the low end of our interval, which you should end up with an answer of 1,750.6312. On the high end, we're going to take this 1873 and we're going to add our margin of error. So we're going to take 1873. We're going to add to it 122.3688. And the high end answer is 1,995.3688. And again, as I mentioned in class when we were learning this before our break, you would typically on a spreadsheet that you might, or a printout that you might get from a computer program, you would see the low and high answers presented in an ordered pair in numerical order with a comma separating them. And typically they would indicate that this was a confidence level of 0.95, and then this would be centered usually underneath it. So this is our confidence interval, right? So what is it that we've actually proven? Well, that's what we want to go ahead and write an interpretation for. So remember, you start off with your confidence, so we'd write I am, or the company is 95% confident. And then you want to talk about the population mean, because that's what we're trying to infer here, the population's mean. And then you want to go back into the problem and figure out what it was that this scenario was supposed to be about. We wanted a confidence interval for the population's mean amount spent on restaurants and carry out food in this age group. So let's bring in a little bit of context. So we'd say the population's mean amount so just pulling the words right off of that last sentence. Spent on restaurants and carry out food is between, and then you bring in your values using units and feel free to round according to the units that you're in. Since we're talking money, I'm going to round it to the nearest penny. So $1,750.63, $1,995.37. And there's our confidence interval.